Okay, now let's see the application of the IP. We say we have lots of relationship protocols with the IP. The first one is ARP. So what means ARP? Let's see the scenario. For example, now we have three computers, right? Host A, B, and C. And each host we have the IP address and the MAC address. Now we want to test the connection between the host A and host C. Pay attention. About the host A, I will directly use the command ping1.1.1.3, and then the host A will send out the ICMP packets. What means test the connection? If I give you a message and you can give me a reply within the certain time, that means the network connection is ready. So, if the host A want to give the message, host A also have to encapsulation successfully. So how to do the encapsulation? What's the information? Host A will use a date, and this protocol is ICMP. We will add some message on the ICMP. And the key point of the network layer is the source IP and destination IP. Of course, pay attention. Except these two parameters, we also have the other information on the IP header I talked before, right? But we only focus on these two parts. The source IP is 1.1.1.1 from the network card of host A. The destination IP is 1.1.1.3 from the ping command, ping1.1.1.3. And then we have to continue encapsulation and the data link layer information. The first one is source MAC address, and then the destination MAC address. About the source MAC address from the network card of the host A. But pay attention. About the host A, don't know the destination MAC address, right? Why about the host A knows the destination IP address? Because we use the command ping1.1.1.3. But we don't have the path, we don't have any way to get the destination MAC address. If you don't know this information, we cannot encapsulation successfully. So we need some tool to get the destination MAC address. And this tool we call is ARP. So before we encapsulation successfully of the ICMP packets, we have to use the ARP to get the destination MAC address at first. So host A will send out the ARP packets, and the function of ARP is, hello, I want to know the IP address of 1.1.1.3. What's the MAC address of this one? And if someone receives this information, I will give you a reply. My MAC address is something like this. So this is a function of ARP. Of course, if you want to get this information, host A also have to send out the ARP successfully and then get the reply. So the ARP also have to do the encapsulation. Let's see the detail. About the date, we have to add the ARP information. The first part, pay attention, this belongs to the ARP message, not belong to the network layer. It's not the IP header. So pay attention about this one. About the ARP message, we will add the standard MAC address, standard IP. Standard MAC address is a MAC address of host A, and standard IP will become 0. Target MAC address will become 0 because we don't know what's the MAC address. The target IP is 1.1.1.3. And this packet we call is ARP request. And this request function is I want to know the target IP 1.1.1.3. What's the MAC address? Okay, so this is the meaning. And then this ARP message will directly add the data link layer header. That means add the source MAC address and the destination MAC address. About the source MAC address is a MAC address from host A network card 00E0FC01.1.1.1. And the destination MAC address will become OF. Okay, so this is ARP request. And this ARP request we call also is broadcast because your destination MAC address is OF, right? And this message host A send out is broadcast the ARP request. I want to know the MAC address of 101.1.3. Because this is a broadcast package, so within the same broadcast domain, all the terminal includes host B and host C. All of them will receive this information, right? And what's the next step? Let's see. ARP we call is Address Resolution Protocol. Okay, and what's the next step? B and C, both of them will receive this information, right? And then host B will say, host A found me, and I am the target IP that host A wants to know. So host C will do two processes. The first one, host C will record the host A IP address information. The IP address is 101.1.1, and the MAC address is 00 and 11111 into the ARP table. Because next time maybe I also will send the message to host A, I can directly search the ARP table and then to get the information to do the encapsulation. The second step, because host A find host C, so host C will give a reply. And about this ARP reply is a unicast reply. Pay attention, unicast means I only send one person. Why host A at the beginning only can send broadcast packets? Because I don't know the information of the host C, so I only can send out broadcast packets. If all the time we send out the broadcast packets, this is a waste of the resources because like the host B, actually, I don't need to receive the broadcast ARP packets, right? Because I'm not the target that host A want to know. So in the scenario, if we can send out the unicast, we don't hope to send out the broadcast packets. So about host C, I will directly to reply use the unicast packets. And the send MAC address is the host C. The send IP address also is host C. And the target of the MAC address is host A. The target IP will become 0. Then the different one is the source MAC address and destination MAC address. The source MAC address is host C and the destination MAC address is host A. Then this packet will be sent to host A and host A will receive it. And the next step is, because host A already gets the information from ARP, then I can encapsulate the ICMP packets successfully. Then I can directly send out the ICMP packets to test the connection. So this is all process of the ARP, what's the function. We see about the host C, we have two processes. The first one, we will add the IP address and the MAC address of the host A into the ARP table, right? Because next time, I can directly use this information to do the encapsulation and send to host A. The second step, I will give the reply to tell the host A what's the MAC address of myself. But pay attention about the host B. Host B is not the target of the host A, but host B also will record the MAC address and IP address of the host A into the ARP table because next time I can directly use this information. So these are a little different. This is a function of the ARP. And in this process, after we get the MAC address information, we can encapsulate the ICMP packets successfully. So what's the function of the ICMP? Let's say the next protocol. And about the ICMP is Internet Control Message Protocol. And this reports errors and failures during the IP address transmission and also can provide the network diagnose function. So this is the main function of ICMP. And we can divide the ICMP packets to become two parts. One is error message and another one is query message. And usually we will use a query message to test the network connection is ready or not. If not, we can use ICMP error message to find the detailed reason to do the troubleshooting. So, for example, host A and host B may be in the same segment, maybe belong to different segment, right? For example, host A IP address is 1.1.1.1, but host B is 2.2.2. Of course, between A and B, we have lots of network to make the routing successfully, and we can follow the traffic. And after we add the communication, we successfully to add all the configuration of the network. Now we want to test the connection between host A and host B. Host A will send out the ICMP equal request. And this function is ask you, can you hear me? And the destination IP is 1.2.2.2.2. All the network devices receive this request packets. I will I will check my IP routing table and then to find the best path and forward to the destination. And if host B receives this message successfully, and I will give a reply. Yes, I can hear you, and then this packet we call is equal reply. If within the certain time I can stand out and also can receive this message, we say the network connection is ready. If not, we will send out the other tools to find the reason why I cannot. What's the key point step or what's the key hop is broken. So this is a function of ICMP. And not about the ARP, about the ICMP, all the terminal have to do the encapsulation, right? And we have to add the layer 2 information of source MAC address and destination MAC address. And we also, in some scenario, we have to add the layer 3 information of the source IP and the source destination. So in this process, we have to know some principle about the host. When we add the information, when we do the encapsulation, what's the correct destination we have to know? We have to let the ARP to get the correct destination MAC address. If the router receives this message, how to define? I will directly do the de-encapsulation or maybe to check the IP routing table to forward it again. So what's the principle? Now let's see the detail. First scenario, if now the terminal, the host want to send the unicast IP packets, what's the key process of the terminal? This is a process. First, if the upper layer protocol requests sending the data packets, for example, now we on the DOS of the terminal, we use a command ping 1.1.1.3. This is the ICMP protocol. Ask the host, you have to do the encapsulation. Another example, maybe now you open the Google and open the website and you want to see a news. This also is a protocol of HTTP. Ask the terminal devices. Now you have to send out the HTTP packets and then you can get the picture or get some words from the server. So this is upper layer protocol request sending out the packets. After the host gets this requirement, we have to do the encapsulation, right? The key point, source IP address and destination IP address is very easy to know. Like the ping 1.1.1.3 already tells the terminal who is your destination MAC and destination IP address. But how to get the destination MAC address? Someone maybe say, I will use ARP to get. The key point of the host is whose MAC address you have to ask. Someone maybe say, I will directly to ask the destination IP MAC address. Actually not. About the host, we will divide the information to become two parts. We have to check the destination IP address is directly connected or not. if the destination IP address is directly connected, we will reserve the destination of the host hardware. If not, we will reserve the gateway hardware. So, the key point, we have to check the destination IP is directly connected or not. So, how to check? The key point is we have to compare the network number. If the network number of the destination address is same with the host, that means we directly connect with the destination IP. So I will give you some example. Pay attention. We have two addresses, 10.1.1.1, 10.2.1.1. So how we know the network number is correct, is the same or not? We already know the IP address of classification, right? 10 classification A, B, and C. About the 10.1.1 or 10.2.1.1 belongs to class A. About the class A, the network part is the first 8 bits, and the rest 3 parts belong to the host part. So, if the first 8 bits are same, we call the network number is same. So compare the first one, they are same, right? And another example, if we use the two IP address 172.16.101 and 2.1, this belongs to the class B. About the class B, we have the network part is the first 6 bits. The last 6 bits is the host ID. So compare the first 6 bits, they are same. So both of them also belong to the same directly connected. But about the last one, 192.168.101, this belongs to the class C. And about the class C, the first 24 bits belong to the network number. So compare with the first 3 parts, they are different, right? The third part is different. So they belong to different. They are not directly connected. So if we compare the directly connected or not, will directly have the influence of which MAC address we have to get. If they belong to the same segment, I will directly to reserve the destination host hardware. That means I will directly ask you, hello, IP address 10.2.1.1, what's your MAC address? Then, after we get the MAC address information, I can do the encapsulation. And the next one, if we find the destination are not same segment with me, I will ask the gateway to help. What means ask a gateway to help? I will direct it to use the ARP to get the gateway MAC address. Hello gateway, please tell me your MAC address. I need your help. Then I will do the encapsulation. Your destination MAC address will become your gateway MAC address. So this is different. So that's why when you do the configuration of your IP address, you have to add the IP address, the mask, right? And also you have to add the gateway. So gateway will help you if you want to do the communication between different segments. It's very important, okay? So this is a host if we want to send out the unicast IP packets. Then maybe you send the message to the router, and the router have to forward the unicast IP address. And what's the principle? Let's see the detail. First, when we receive the IP packets, this one we call is packets inbound. Then we also have to do the de-encapsulation, right? De-encapsulation means delete the physical layer header, delete the data link header, delete the network link header until sees the information. So when the router receives the packet, how to define which header I have to delete? The first one we have to check whether the destination IP is native. What means destination IP is native? If the packet I receive, the destination IP is the IP address of the router interface. That means this packet will directly give the router. I will delete the data link header, delete the network layer header, delete the transport layer header until to give the information of the app layer. So this is the step of submit native app layer protocol to process. So this is the first one. I directly send the message to the router. For example, you do the telnet to the router, right? And another one, maybe I only need the router to help us to forward the packets. I not send the message to the router. So we will go the next step. No, the destination IP is not the native. That means you have to help to forward the packets. So when you do the help to the forward the packets, I will take the destination IP address and check to your IP routing table, right? Because the IP routing table will help router to know if you want to send the message to the destination, your correct interface is the left one or the right one, the first interface or the second interface. So this information, all of them recorded in the IP routing table. Then the next step we have to check whether the destination IP is directly connected or not. Pay attention about this one. If yes, I will directly reserve the destination host hardware address. That means I will directly to ask the destination IP address what's your MAC address. Because about the router also have to do the encapsulation again to forward the traffic. But pay attention, if not, that means if you want to forward the IP address, the IP packets to the destination, you still to have forward the information to the next router or to the next layer 3 switch. The destination terminal is not directly connected with this router. In this scenario, you have to reserve the next hop router hardware, right? Because you have to ask your next router, maybe router B, please help me continue to forward the information. Why router B will help you? If you give the packets to router B, and the router B will find the destination MAC address belong to myself, then I will continue to delete the layer 2 information, delete the MAC address information, and take the destination IP address to track my IP routing table, and then to help you to do forward. So this is the process of router B. That's because router A already added router B interface MAC address into the packet, and then router B will do the check. So router A have to reserve the next hop router hardware. After we get this information, we will do the encapsulate packets and then send out. So this is very different. Who you have to ask to get the MAC address, right? Of course, in this process, you don't need to do any configuration. The router will ask automatically. They will know what's the IP address. We have to know the MAC address. This is a process. So, if the network number of the destination IP address is same with the number of any interface of the router, that means the destination is located in the network segment. This is the first one we have to check, right? And the second one, if the router determines the address of the next hop router by looking the routing information, right? Who is your next hop? I also will check my routing table to get this information. So this is a process of the router. Of course, the same process of the layer 3 switch. If the layer 3 switch forwarding the packets according to the IP routing information. The next one, when the host receives the IP packets, right? The first scenario is host send out the packets, and the media router may be directly to deal with the packets, maybe help to forward the packets. Then if the host receives the unicast packets, how to do the process? Pay attention. First one, if we receive this information, we have to check whether the destination IP address is the host. If not, that means I will directly discard. If yes, I will do the de-encapsulation and submit the packets to the upper layer protocol to do the processing. So, what means yes? We have to check the packets information. If the destination IP is the own IP, that means I need to check the packets. The second scenario, if the destination IP address is a broadcast IP address. Broadcast means if you are in the broadcast domain, you also is a member of the domain. You have to receive it. The third one, the destination IP address is a multicast IP address, and a series of you belong to this multicast group. You also is a member of the group, so you also have to check. Except these three scenarios, when we receive the packets, I will directly discard. Okay? So this is the host receives the information. Otherwise, the host network layer will discard the packets. I will not do the de-encapsulation again to delete the network header and delete the transport layer header. No, I will directly discard. So this is a process. And in the network layer, we say the IP address is very important, right? And a very important device is a router. Also, you can say is a layer 3 switch. And in this topology, the router can help to forward the packets between different segments, right? From the left one to the right one. And different segment means this segment's network address is different. Okay, so this is the function of router. But pay attention. If one switch sends out a broadcast packet, that means the destination IP address will become all 255. Okay, 255.255.255.255. Do you still remember? This is a special IP address in your network, and this is the whole broadcast packet. And by default, if the switch receives this broadcast, I will reply to everyone. In this scenario, if router also help us to forward the broadcast packet, that means in the network, everyone will receive this information. So this one we call is broadcast stall. In order to avoid the broadcast stall, by default, the router cannot forward the broadcast packets. Okay, so this is a default. If the router receives broadcast packets, I can give some reply. If for example, like the ARP request, and the ARP request asks the gateway to help me and tell me the MAC address, I can give a reply. But I will not forward the broadcast packets in order to avoid the broadcast stall. So we say about the router, we can limit the broadcast domain, but the switch cannot. Okay, so this is a key point of the router. At last, there are some questions of this video. The first one, the natural classification network address corresponding to the IP address 112.1.1 is what's the broadcast address? So that means can you calculate the correct network address and broadcast address of the 112.1.1.1? And the second one, please calculate the number of available host address. Pay attention about this one. Available host address. contains the natural classification network segment of the IP address is 172.12.15.1.1. What's the number of available host address? And the next question is, which of the following statements about IP address is true? Please choose 3 correct answers. Option A, IP address consists of 2 parts, network and host. Option B, the network number of class A IP address has 8 bits, and the actual available digits are 7 bits. Option C, Class D IP addresses are usually used as multicast addresses. Option D, the first octet of the Class C IP address starts with 100. Please choose the true answer. That's all about this part. Thank you.
Hello everyone. Now I think you already see the training video, right? Let's have a brief summary for you. About this part, the very important one is IP address. It has 32 bits long and it has 2 parts. The first one is network part, the second one is host part. And we can use the IP address to indicate the network device, like the router, like layer 3 switch. And also we can use the IP address to indicate the host. And the second part, we explain about the routing information. We have some dynamic routing like the OSPF, BGP, and this. And in the network, if the host wants to send out the packets between different segments, the host will ask the gateway for help. So the router will help the host to forward the traffic between different IP segments. So this is the function of the router. And besides this one, we also explain something about the ARP. If we get the IP address, how to get the MAC address? This is a function of ARP because we have to encapsulate the packets fully. That means we need to have the source and destination IP address, source and destination MAC address. So how to get the destination MAC address? We will use the ARP protocol. And the last, we explain something about the ICMP. This is used to detect the connection between different networks. If I send out the ICMP packets and you can give me a reply within the time, I think the network connection is ready. That's all about this part. Don't forget to finish the practice I assigned for you. Thank you.